Welcome to module 21. In this module, we will start looking at the footprints. Footprints are a measure of individual resources and they are very useful when the concern for sustainability assessment is one single resource. In this module, we will go through a quick introduction to footprints and then we will look into detail into the ecological footprints. So, what are footprints? We have seen the life cycle impact assessment where we convert most of our inventories, life cycle inventory into the midpoint indicator or endpoint indicator. Your midpoint indicators are specific impacts that we are concerned about, such as eutrophication, acidification or global warming potential, for example. And your endpoint indicators go into the damage categories of ecological impact, human impact or the environmental impact. We also looked at the thermodynamic assessment where the focus was more into looking into the energy efficiency or the exergy efficiency, and we also went all the way to the ecological work done, which is the ecological cumulative exergy consumption. Lot of times when we are thinking about sustainability assessment for products and processes, we are also concerned about the use of specific resources as we are becoming very resource constrained. Some of the examples of constrained resource are land availability. So, ecological footprints are specifically concerned about the land availability and how the human consumption of different products and our processes are exceeding the capacity of the earth to provide those resources in terms of land availability. We also looked at carbon footprint. So, carbon footprint is related directly to the global warming impact. This is one of the emissions that is of concern for the global warming and it also comes in the life cycle impact assessment. So, in terms of footprints, carbon footprint is a little different than the rest of the resources, which are mostly the resources availability, but this is more of an impact. And the reason we think of it as a footprint, because there is an assumption that there is a limit to how much CO2 we should be putting out in the atmosphere based on its impact on the atmospheric global warming. There is also other emissions such as methane and N2O which has global warming impact, and hence the carbon footprint is not really just focused on one particular resource or emissions, but has multiple. It is more towards the impact and our capacity to actually exceed that limit. Nitrogen footprint would be specifically on the nitrogen flows and water footprint is about water, and we will get into the details of each of the resources and how these footprints are proposed as metric for assessment of sustainability. So, let us get started with the ecological footprint. Ecological footprint is kind of a resource accounting method. It measures how much biologically productive land and water area as an individual, a city, a country, a region or humanity uses to produce the resources it consumes and to absorb its waste it generates using prevailing technology and resource management. So, in short, what that means is that if we are consuming products and if we are making processes that are making that product, then there is a requirement of land area that is required to provide the resources for those particular products. There is also an idea that when we are putting out emissions or waste in the atmosphere or ecosystems, we are consuming some land which could be available for the biological productivity, but it gets lost because it is now available to take care of the waste that we have put. So, all of that activity that consumes resources and also produces waste has a contribution to the land consumption or the land appropriation by human activities, and that is what is known as the ecological footprint. The unit of ecological footprint is mostly expressed in the units of global hectares, and what it means is that we are kind of equivalent, we are kind of representing all the land available in the world as one average unit, which is the global hectare. So, we are normalizing the local hectare. So, if we are making a production or if we are doing production in India versus China or versus United States, the productivity of the land will be very different. But since we want to harmonize the metric, we represent all of that in a global hectare, and by taking the world average productivity of all biologically productive land and water in a given area. year. You can see that this will be a very involved calculation, because this involves understanding the productivity in the heterogeneous land utilization that we are doing as based on our human activities, and also water utilization, which refers to the freshwater or marine land. So, the idea is that whatever we are consuming in land is the ecological footprint, but biocapacity is actually the limitation. So, we are concerned about the resources where we have limitation of use. So, here biocapacity is the capacity of ecosystems to produce those useful biological products and also assimilate waste. So, anytime we are exceeding this biocapacity, we are going to say that our ecological footprint is unsustainable. We also measure the biocapacity in terms of global hectares. So, in any given year, we would know what is the capacity of the ecosystems globally to provide those resources, and how much from the ecological footprint we can know how much is our actual footprint in terms of productive land. The biocapacity is calculated for all biologically productive land and sea area, and biologically productive land is defined as where active photosynthesis activity happens and biomass grows that can be used by humans. When we calculate the biocapacity for our earth system, we do not include the non-productive and marginal areas such as arid regions, open oceans and other low productive areas. Any protected land that we are not going to use for the consumption of resources or production of resources for human consumption will also go into the non-available area. Areas that produce biomass but are not of use of humans, for example, some of the dense Amazonian forest that needs to be protected, should not be calculated in biocapacity, because that is something that has to be away from human activity. Then there are different land types when we do our ecological footprint calculation. The first is the cropland, then forest land, grazing land, fishing grounds, which all has both freshwater and marine, built up land and carbon land. Cropland is straightforward. It is the area that includes all the active area in production of agricultural products. So, all the active crops all across the world, they are used in the footprint calculation. Forest land is something where we are creating timber for use for human beings. So, that is the productivity of the forest to provide resources in terms of pulp and paper and other cardboard etc. that is based out of timber is considered into the forest land type of product. Grazing land is the pasture land. So, there are all across the world there is a lot of reliance on the livestock industry or also on for leather or other kind of product or maybe food production, and that is the grazing land which is supporting the livestock industry. So, it is dedicated land that is for pasture, and those pastures have some economic product that is going for consumption. Fishing grounds for both freshwater and marine, these are mostly continental shelves that exclude the inaccessible part of the ocean, and because that is considered unproductive water. There is also inland water which is about 0.4 billion hectares, and we have the inaccessible unproductive land, waters are not included. So, that area of land provides the area for the biocapacity of a calculation of footprint for the fishing grounds. Built up land is infrastructure which we directly use for human habitants, and that is what we call as the infrastructure land or built up land. There is also something what is defined to assimilate the waste, where we have defined an imaginary land which is called carbon land. And why we call it as carbon land is because each of the land area that is available, excluding the, it does not include the ocean sequestration. So, a lot of CO2 gets absorbed by the ecosystem, which is the service provided by the ecosystems. So, that land is also included, and that is termed as the carbon land. It is used to calculate the required land for sequestering the emitted CO2. And notice that even though ocean carbon sequestration is a big component of mitigating our CO2 emissions from human activities, the ocean carbon sequestration is not included in the carbon land. and for the marine land we are only including in terms of the fishing productivity and not for the CO2 sequestration. Going forward, there would be definitely suggestions for including the carbon sequestration to actually account for how much overshoot we are doing for the available carbon sequestration services from the ecological systems. So, the components in ecological footprint and biocapacity. So, ecological footprint we include croplands that provides the crops, grazing area for the pasture land and support of the livestock industry, fishing grounds that is the direct product in terms of fish, forest for timberland, and then carbon area which is included in the ecological footprint, but it is not a separate land in the biocapacity. It is going to be all the same land that has the capacity for carbon sequestration. And then the built up area is just the available area that is available for human built up infrastructure. So, what we do is we calculate the ecological footprint for each of the products and process at the life cycle scale or even at the single stage process level, and then we can compare it with the biocapacity of the world, or we can also compare it with the biocapacity of the area or the region that we are interested in. That gives an idea about the sustainability or unsustainability of your product or process that you are studying. So, let us look at how we calculate the ecological footprint. So, when we are making a product or when we are growing a crop, we are generally focused on one particular region. So, let us say we are growing cotton in the south of India or we are growing rice in West Bengal. Each of these land will have different productivity. But when we calculate ecological footprint, we want to normalize it into what we call as the global hectares by including or by calculating the average productivity of the land, and to convert that local hectares of the land area that we are using for the product into the global hectare. We use some things like equivalence factors and yield factors. So, we will see what equivalence factors and yield factors are. When we have these two values, we can convert any regional land into what is the unit for the ecological footprint in terms of global hectares. So, let us see what is the equivalence factor. Equivalence factors is used to translate a specific land type, that is cropland, pasture land, forest, fishing ground. All of those are diverse. You cannot substitute a cropland for a freshwater land. So, there is no substitutability, and therefore, you cannot add these hectares into one. So, in order to calculate a single metric of ecological footprint, these are normalized into a universal unit of biologically productive area in terms of global hectares, and it is calculated on an annual basis. So, for different years it is different, and it is calculated based on global average productivity. So, ecological footprint so equivalence factor can be seen as very similar to characterization factors, where you are taking your inventory and converting it into one type of impact. Similarly, here with the equivalence factors, what we are doing is we are taking a one type of land and we are converting it into the impact in terms of the global hectare, which is the average biological productive area available for mankind. So, here are some examples for 2003 from the ecological footprint, and these numbers are revised by ecologists most of the times. So, here we have the primary cropland, and the equivalence factor you can see is 2.21 global hectare per hectare. So, one thing you would notice is that the productivity of primary cropland is much higher, about more than 2 times than the average productivity of the global hectare. Similarly, forest is 1.34. Grazing land is really low, 0.5, marine land is lower, 0.36, marine and inland water are given the same value. Built land has a high productivity factor because it is considered very high productive unit for the human consumption. So, in this case you can see that cropland in 2003 was more than twice as productive as a land with world average productivity. Similarly, you can say that forest was about 1.5 times more productive, and the productivity is measured in terms of unit product that is of value to human being. Next is the yield factor. So, what yield factor does, it kind of says that now we have same kind of land in different region, and since there is a difference in the productivity of each area, we will convert this into one region. So, for example, your world average yield for primary cropland is of course 1, because that is our normalization factor. But we can see that for different countries, your primary cropland has a different yield factor. So, we can see that your Guatemala is of course very close to the average productivity of the global hectare, but your Hungary is also 1.1, Japan has a higher productivity 1.4, but Zambia is really low in terms of 0.5, which means that same hectare of cropland in Zambia is not the same as the same hectare of cropland in Japan. So, you would say that anything, if you are growing crop in Japan, you will have a higher ecological footprint because you have a higher yield, that is you are getting. So, you are consuming resources of higher quality. Similarly, you would have difference in the yield factor for the forest land, grazing land and ocean fisheries. So, you can see that Hungary has really good in terms of the ocean fisheries, but and also in terms of forest and grazing land, but you have really bad forest productivity from Zambia. So, this kind of yield factor is calculated every year to convert the land for each country or each region into as compared to the world average productivity, so that when you are calculating your ecological footprint for a region, you can convert that into the equivalence of the global hectare. With these two numbers in mind, the equivalence factor and yield factors, the ecological footprint calculation is a simple translation of these numbers. So, we start with the calculation of PI, which is, let us say, the product that we are consuming in mass units or other relevant unit. It can be any resource input to your process as well. So, let us say we are making a bio-based chemical. So, any biomass we are putting as an input to the process can be our product. So, that is the product being consumed in mass unit or any other relevant unit. YNI, which is the denominator, is the annual national average yield for the production in terms of kg per hectare. So, let us say you are making that biomass or product in one country, then you can divide that product by the yield, so that you know how much land area is required to make that product that is an input to your process or whatever product you are looking at. Okay. So, now that the first part of this equation is then giving me the local hectare. So, it is giving me what land is required in the region where I am calculating the ecological footprint for producing the product that is an input to your life cycle, or it is the product of your life cycle. Then we multiply it with the yield factor. So, yield factor, what it does is that you will get into global hectares per hectare. So, what is doing is that now you are basically converting your hectare per hectare. So, what it is doing is that it is converting the land. So, instead of saying that now in this region, let us say what will be the land required for the global average productivity, and that is the multiplication by yield factor. So, what these two terms will give you, it will give you the hectare of land in terms of global average productivity for that particular type of land for the product making, and then we multiply it with the equivalence factor. When we are multiplying with equivalence factor, we are removing the type of land and we are now converting all of the land into one type of land, which is global hectare. So, the unit for this will be global hectares per hectare, and there you would see that you can multiply and you will get basically the total ecological footprint in terms of global hectare. So, once again, the first term is giving us how much land is required in that particular region. Multiplying by the second term, which is the yield factor, tells us the how much land on an average world productivity will need, and then multiplying by the equivalence factor, we would, and that is in that particular category, whether it is cropland or fish land, and then we multiply by equivalence factor, and then we get how much land is required in terms of global hectares for making that product. So, that is a very straightforward calculation of ecological footprint, and we will see an example of how to do a ecological footprint calculation for products. So, let us look at this example. in this example, you see that someone has an LCA analyst has conducted the LCA, and for the functional unit, they have the total amount of grass input as 10 kg per functional unit. Fish input required in their process is 5 kg per functional unit, and the CO2 emissions from their process is 10 kg per functional unit. The table gives you the yield and the bottom table gives you the equivalence factor. So, I would ask you to use the equivalence factor and yield factors that are provided for year 2003. We are also giving the average global productivity of grazing land for as 5 kg per hectare, and the marine fisheries was 0.5 kg per hectare. So, you also know the productivity in terms of per unit land. So, and we are asking you to assume that the country of resource origin is New Zealand. So, take 30 seconds and let us just calculate the ecological footprint associated with grass first. Okay. So, let us look at the solution. Our ecological footprint equation is given as summation I So, here let us look at the grass input. So, for grass we had 10 kg of was the input to the process for the production, and the average productivity of the grassland was given as 5 kg per hectare for the globally. And then we are saying that this product is being obtained from New Zealand. So, our productivity factor or the yield factor for New Zealand is 2.5. So, if I have to get the proper hectare, it is going to be multiplied by 2.5, and that converts it into the hectare for New Zealand, and then we multiply by the equivalence factor. So, we want to calculate the global hectare. So, for grazing land the equivalence factor is 0.49. So, we multiply by 0.49, and that is where we get the global hectares. So, this will come out to be 2.45 global hectare will be the ecological footprint for the grass input for that product. Let us look at the fish input. So, your fish input is now we have is given as 5 kgs. So, we have the 5 kg of fish input. The productivity, average productivity was given as 0.5 kg per hectare. We multiply by the yield factor. So, for the fisheries where the yield factor is 0.2. So, we multiply by 0.2, and the equivalence factor for fisheries land is 0.36, both for inland water and marine. So, we multiply by 0.36. So, the ecological footprint associated with fish consumption is 0.72 global hectares. And then the last is our CO2 ecological footprint. For that the information provided was, let us see. So, the information provided for ecological footprint. So, CO2 emissions is the global rate of CO2 sequestration is given as 20 kg per global hectare. So, you are directly given how much global hectare is needed for sequestration of 20 kg. So, 1 global hectare. So, we can calculate the global hectare required for the CO2 emission. Here the CO2 emission is 10 kg. So, that means our CO2 will be 10 kg divided by our 20 kg global hectare. So, that will be about 0.5 global hectare. So, the total ecological footprint in this case will then be 2.45 plus 0.72 . So, the total ecological footprint of making this product, which requires grass, fish and has a CO2 footprint, is equal to 3.67 global hectares. Okay. So, now that we have this ecological footprint, you can do this calculation for various products, and that will give you an idea of what is the resource requirements in terms of land for supporting the production of different products that you are consuming in the life cycle. So, that gives us an idea of what is my sustainability index, or what is the whether this product versus that product is more sustainable in terms of land stress that is created by human consumption globally. So, how do we interpret ecological footprint? We have ecological deficit and ecological reserve. So, for quantifying your ecological deficit, what we will do is we can subtract the amount by which the ecological footprint, or we can calculate the ecological footprint of population or the product consumption, and we can compare it with the available biocapacity of the population's territory in a given area. So, we can calculate the ecological deficit of a nation or an economy, or ecological deficit that is driven by consumption of a particular product. We can also calculate ecological reserve, which means that when the ecological footprint that is associated with the consumption in a particular country or a region, or ecological footprint of a particular product is lesser than the available biocapacity, then there is an ecological reserve. Based on these two comparisons, we can tell whether there is a need to focus on the reduction of the land requirement, or is it okay to continue the production because it is not resulting into ecological deficit. So, we do regularly calculate the overshoot. So, if the consumption related ecological footprint exceeds the biocapacity, then there is a overshoot. You can see that this graph is telling where we have overshoot. So, 1.0 is our biocapacity. So, based on the you can see that our built up land has grown drastically over the years, and now it is about 1.5 amount of earths that is required to meet the built infrastructure capacity. Similarly, cropland and forest are also growing, and carbon dioxide land and nuclear has also grown exponentially since the time from 1961 to 2003. It is expected that it will keep growing. So, in that case, mitigation of CO2 and reduction of the consumption or recycling, so that we do not have to rely on creating more and more resources, is what is suggested for moving towards a sustainable trajectory in terms of consumption of land resources. In summary, the ecological footprint evaluates the resource stress using the land area unit. So, how much stress are we making on our earth system to produce any product based on the land area requirement? It provides a unidimensional metric for comparison of life cycle results on resources consumption, and the limitation is that it is not very useful for the cases of the LCAs that do not involve resources that are not directly generated from land area, such as metallic ores. So, lot of the time we will have metallic inputs, and for that the metrics used from the thermodynamic basis, such as the exergy matrix or the emergy matrix, may be really useful in that case, because it does not directly relate to the productive land area available in the earth system. With that, thank you so much for coming to this module, and I will look forward to see you in the next module.